We've got some big bears to tackle today. As our title suggests, we're not just looking at exponential equations, but we're looking at some advanced exponential equations, and we're going to see some really wild twists and turns here today. So a couple of things that you're going to see, and these may look a little scary, but we're going to see an equation where we have an exponential expression on not just one side, but on both sides. So we might have had 5 to the x minus 2 before, but then we'd have, something like just a constant or something really simple on the other side. Okay. And our second example looks even more intimidating. We have it's an exponential equation, but it's kind of in a quadratic format here. And we're going to talk about how to factor this trinomial and then eventually solve for x. So that's going to be pretty exciting. And I think if nothing else, the nice thing about these really hard problems is that they bring a great deal of pride and self-satisfaction when you're able to conquer them. So how do we attack this when we have exponential expressions on both sides? I'm going to go ahead and I'm going to take the natural log of both sides right out of the gates. Okay, so this is going to be the natural log of 5 to the x minus 2 equals the natural log of 4 to the 2x plus 3. And then again, rewriting these so that those exponents come out front. Now this next move, I can't stress enough, there must be parentheses around the x minus 2, right? Okay, anytime you're working with a binomial or a trinomial or anything bigger than a single term, we've really got to appreciate and value how important those parentheses are. Now from here, what I want to do is I want to distribute and then eventually move things around so that all the x's are on one side and then the terms that don't have an x are on the other side. So I'm going to go ahead and distribute this ln of 5 to both terms. And through a little trial and error, here's how I've decided I want to write these. When I could go natural log of 5 times x, but it gets a little confusing. Like, am I taking the natural log of 5x? Or am I just taking the natural log of 5 and that's multiplied by x? And the latter is the case. But the easiest way to communicate that is to just say x ln of 5, and then there's no uncertainty as to who you're taking the natural log of. Minus 2 natural log of 5 equals, we'll say 2x natural log of 4 plus 3 ln of 4. And like I said, I want to try to get the terms that have an x in them on the one side together. So what I really want to do is I want to try to get this term and this term on the left side, and then I'll move this term over to the right side to join this term over here. So that's my game plan. Okay. So the first thing I'm going to do is I'm going to subtract this term to the other side, okay, so that those cancel. And I get x ln of 5 minus 2x ln of 4. And then I'm going to add this term over to the right-hand side so that those cancel. I'll have 3 ln of 4 plus 2 ln of 5. Whoopsie, that got messy. Okay. Now, here's maybe where the biggest stumbling block might lie. I'm going to take a GCF out of this side right here. So once I factor the x out, I'm left with the natural log of 5 minus 2 natural log of 4, right? Told you this was a big bear. Tackling big bears today. Now, we're in the clear now. We're just going to go ahead and divide this quantity to the other side. I'm going to divide both sides by the ln of 5 to ln of 4. Whatever I do to one side, I got to do to the other. So that these cancel, and you're left with x equals all of this right here. And if I plug that all into my calculator real carefully, negative 6.343. And then again, you could always store that number and then substitute it back into the original problem as a real nice check to confirm your answer. That's what I love about these. They're really, at first I'm like negative 6.343. That's such a weird answer. I don't know if that's right. But once you save it, store it, plug it back in, you can confirm that it is indeed right. All right, very, very similar problem. We've got an exponential expression on both sides. I'm going to start off by taking the natural log. And we just need lots of good quality practice and reps with these crazy suckers. All right, we're going to rewrite these with the exponent out front, making sure that we appreciate the importance of those parentheses. Without the parentheses, it totally changes the problem. Now we're going to go ahead and distribute. And here's how I prefer to write it. I'm going to say 3x times the ln of 2 minus 1 times the ln of 2 equals x times the ln of 6 plus 1 times the ln of 6. Critical move right here. We want to try to get this term and this term on the same side together, and then we'll try to get this term on the same side with this term. So I want to group those accordingly. So let's do this. Let's subtract x ln of 6 from both sides. Okay, and then I'm going to add the ln of 2 to both sides and try to get that over to the other side. So we were left, we've got 3x ln of 2 minus x ln of 6 equals the ln of 6 plus the ln of 2. How crazy are these, huh? Does it feel like you're doing some big time math? I hope it does, because you are for sure. Okay, what do you want to do next? What do you want to do next? The whole reason we wanted to kind of move those terms around and get all the x's on one side is to set ourselves up for this move right here, and that's the GCF move. We're going to factor an x out. So we've got 3 ln of 2 minus the ln of 6. And then we're just going to divide both sides by this big quantity right here. And once we do this division, we can pump this big bear into our calculator. And that's, we know those cancel. And we get x equals, looks about 8.638 on this one. Again, store it, save it, plug it back into the original. Always, doesn't matter whether you're solving exponential equations or logarithmic equations or linear equations. When you get to that point where you want to do your check, it's really easy. Just plug it back into the original. Always plug it back into the original. All right, we're going to shift gears to this other crazy topic we want to get into. And before we really get into it, I just want to review and practice a little bit of multiplying. In this case, what I like to call foiling. And in all foiling really is, it says, okay, we're going to distribute the first term, and then we're going to distribute that second term and combine like terms where appropriate. So what is e to the x times e to the x? I'm going to make a little note over here. When you multiply these two rascals, what you're really doing is adding their respective exponents. So the product of e to the x times e to the x is e to the 2x, e to the x times negative 3, 4 times e to the x, and then 4 times negative 3. Combine the two terms in the middle. So you get plus 1 e to the x minus, whoa, did I just write that backwards? What the heck? E to the x minus 12. And actually, this is as far as you can go. You can't combine, we can't combine this term with this term because they're not like terms. Why are they not like terms? They're not like terms because they don't have the exact same exponent. So that's as far as we've gone. Now let's practice this next example in a similar fashion. So when you start distributing and you say, you know what, I'm going to multiply e to the 2x times e to the 2x. Again, add their respective exponents. So you're going to get e to the 4x minus 6e to the 2x minus 2e to the 2x plus 12. Combine the like terms in the middle there. If you do have like terms, they're most likely going to be in the middle. So we're going to get negative 8e to the 2x plus 12, and there's no more like terms, so that's our final product right there. Well, what we're going to do today, when we say we're going to factor, we're going to do the exact opposite of what we just did with the multiplication. So factoring is the undoing of that multiplication. And so when we see an exponential equation in what we call quadratic form right here, we're trying to factor this guy. And we'll start off with, what are the multiples of e to the 2x, right? We're thinking e to the x times e to the x is going to produce e to the 2x. Now I need the multiples of 3 that just happen to add up to negative 4, which is going to be negative 3 and negative 1. Again, if you have any hesitancy or any lack of confidence that we factor that correctly, you can always FOIL those two pink expressions together to see if you get the original quadratic form. So what I'm going to do right now is we're going to use the zero product law to tee this bear up. We're going to say e to the x minus 3 equals 0, or e to the x equals 3. Here's where we'll take the natural log of both sides. Move that x out here. Ln of e is 1, so x just equals the natural log of 3. And if we had to go decimals, we could plug that into our calculator. On the other side, we'll add that 1 over. Now this time, when you take the natural log of both sides, if you remember, the natural log of 1 is just 0. So we get x equals 0. And again, that's a real easy check. We could substitute that 0 back in for the original x's and confirm it. All right. So yeah, just to clarify, your solutions are, I should clarify that here. Your final solutions are the ln of 3 and 0. They both would check. There's nothing wrong with either one of them in this case. Okay, again, looks like I'm missing the equals 0. This should be set equal to 0. And again, so we have an exponential equation written in quadratic form. We're thinking about factoring it. And we're trying to think of, okay, what are the multiples of e to the 4x, right? In this case, we know that e to the 2x times e to the 2x would produce e to the 4x. Now you're thinking, what are the multiples of positive 7 that just happen to add up to negative 8? And so we're going to go minus 7 minus 1. Now that it's factored, we could tee it up and say e to the 2x minus 7 equals 0, or e to the 2x equals 7. Take the natural log of both sides. Notice as soon as I took the natural log, I moved that exponent out front. You could, go a little bit slower than that if you want. We know the natural log of e is 1, so I'll divide both sides by 2. And again, so we could leave it in terms of an ln, or we could convert it to a decimal using our calculator. On the other side of this expression, we got e to the 2x minus 1 equals 0. Add that 1 over, of course. When we take the natural log of both sides, we know that ln of e is 1 and the ln of 1 is 0, so we just get x equals 0. So at the end of the day, my solutions are going to be the natural log of 7 divided by 2 as well as the 0. They both check out. We're in good shape. Whew, now you can take a breath. That was pretty intense stuff tonight. Hope you learned something new. And let's go test our luck and see if we can solve some similar examples.